Let's keep track of what's going on in terms of the unit circle of these multiple values of the sine function that keep coming up in the law of sines and in solving trig equations. We're going to go past the point where we're thinking about the trig functions in a right triangle and think about general angles. So we'd like to look at what's going on for coordinate axes. So here's axes in the plane, and the unit circle. So here's the unit circle relative to those axes. So that this distance is supposed to be 1 unit. The radius of the circle is 1 unit, so no matter what direction out from the center that you take, it is 1 unit out. Now, relative to this circle, we'll put the angle in standard position. So the angle is CBA, and there is indication of how big that angle is here. You could change the angle. It's indicated in this picture as a multiple of pi, and it's a decimal multiple. If you go all the way down here, then the multiple would be 0. Here's the angle up to pi over 2 radians. Notice that we're going from quadrant 1 to quadrant 2. When we get past 0.5 pi, that's pi over 2, all the way around to pi. Notice that arc's following it to show you how the measure's going, round to 1. The angle could also be in quadrant 3 or quadrant 4. And this is reporting that with a negative measure. It could be positive or negative. Well, this angle gives the point A as a point on the unit circle. It's associated with this angle CBA as we've written it, and the coordinates of the point are given as values of the sine and cosine function. Remember, this is the unit circle, so this distance is 1 unit. The sine is this green line that we've put in that measures the y-coordinate of the point. How far up the y-axis you go. This vertical distance, here it is making a triangle, this vertical distance is the value of the sine function. And the cosine function is the horizontal distance, how far out you go along the x-axis. So this distance out along the x-axis, translated up here, this horizontal distance is the cosine. So move the point and those values change. Now, suppose you'd like to consider angles that are solutions to a trig equation. So this green line is a value of the sine function. Its length is the value of the sine function. Here is an angle which has that green line as the side opposite it. It's the value of the sine function. There are other angles that you could choose that would have that same height. If you go across here, there is a point on the unit circle in quadrant 2 that mirrors the point in quadrant 1 that has the same height. There it is. So that we've got two angles, this one and this one, and the side opposite the reference angle in the reference triangle has the same height. The y-coordinate of the point is the same here as here. Same distance up, same y-coordinate for this point as this point. That means the value of the sine function is the same for this angle as it is for this angle. And when you change the angle, you can watch what's happening to the height of that green line and see how it tracks on the left, its value on the right, so that all of these angles, both those angles indicated there, the angle in quadrant 1 and the angle in quadrant 2, both of those angles have the same value for the sine function. Okay.